All right, guys, today we are going to talk about our isosceles and equilateral triangles. So the first thing we're going to talk about is an isosceles triangle. An isosceles triangle has two congruent sides, and we call those the legs. The other side is called the base. So usually, typically what's sitting on the ground. These two congruent sides form the vertex angle. The other two guys are called the base angles because, again, they sit and create the base. Okay, our first theorem today tells me that if two sides of the triangle are congruent, then the opposite angles, we're going to actually change that to say angles opposites. We're going to switch those two words around. It's supposed to say angles opposites. And wording does matter in terms of theorems, so we need to make sure we change that distinction. So then the angles opposite are congruent. The angles opposite those sides are congruent, which means that the base angles are congruent. So if you notice that AC, if we're told that AC and BC are congruent, then that means that angle A has to be congruent to angle B. Again, opposite means that if I were to draw an invisible straight line, I can go ahead and hit that. Ooh, what are you doing? Go back. Let me just retry that. Notice how this angle goes to that side, this angle goes to that side. They're across from each other, they are equal. Theorem 4 tells me that two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it kind of goes backwards. It says that if I'm told that A is congruent to B, then I'm told that AC is congruent to BC. Again, going backwards. Next one says the bisector of a vertex angle of an isosceles triangle is a perpendicular bisector. Perpendicular means creates a 90-degree angle. Bisector is cut in half. So this basically says that if angle C, which is my vertex angle, gets cut, my new line CD creates a 90-degree angle when it hits the base, or the opposite side, and then it also cuts the side in half. So AD is congruent to BD. Okay, a corollary. A corollary is something that follows from a theorem. So because this theorem says that, I can then create this corollary. Okay, first one says corollary 4.3. If a triangle is an equilateral, then it's also equal angular. Okay, let's pull that apart. Equilateral. All right, here we go. Equal sides. Equal angular. Equal angles. So if all the sides are equal, all the angles are equal. Makes sense. If a triangle is equal angular, then it's also equilateral. So again, going backwards, if all the angles are equal, then the sides have to be equal. And then that would also mean that, let's think about this logically. All triangles add to 180 in the middle, or I'm sorry, all of the angles in a triangle add to 180. You have three angles, 180 divided by 3 is 60, so that each angle would have to be 60 degrees. And for some reason, my zeros want to look like a 6 today. All right, let's put some of this into practice. Woohoo! Using the figures to the right, complete each statement below. VT is congruent to what? Well, where is VT? And I'm going to get the highlighter, and I wouldn't recommend doing a highlighter on your end unless you're going to get multiple different colors, because I'm going to erase my highlighter. So maybe get different colors. Maybe different colors would work. That's why I'm missing the letter V. Hey guys, my V got cut off. It's at the top. I'm like, where's my V here? So VT is congruent to, well, if you notice, I have one big triangle in yellow. So ignore the extra lines for a second. Angle T and angle X are congruent, which means that the sides would have to be congruent. So VT would end up having to be congruent to VX. Oh, that's not what I wanted to undo. Okay, next one. UT would have to be equal to what? Well, where's UT at? UT is here. Now, if you notice, I have a small little triangle over here. And T is equal to W. So he creates his own little equilateral triangle. Let me try that again. He creates his own little isosceles triangle. So that means that UW must also be congruent. Oof, that U is a little rough. I was trying to do a lowercase u. It didn't really work out. Which is also equal to yx. Because if you notice in the highlighter, it's tick marked. So of course they all have to be equal. If it's got a tick, it means they're equal. All right, VU. Where is VU? This guy is equal to, well, if you notice, I have a little triangle here. And he would end up having to be equal here and here. So that one's going to have to be VY. I was hoping for black, but you know, we're writing green. That works for me. And then my last one of V to Y to U, VYU has to be equal to, well, we just proved that angle. And we need to say V to U to Y. All right, next one. We're going to go ahead and determine the values of X and Y. Now recall, and I want you to write this down if you haven't already, interior or inside angles add together to be 180 degrees. In a triangle, all interior angles add together to be 180 degrees. So let's tackle this one right off here to the side. We're going to do it. Well, I see that I have equal sides. So this guy, okay, that's not what I wanted you to do. Thanks, computer. So this guy is equal to this guy, which means that I have equal sides and equal angles. Whatever. My computer's having a good time right now. So if he's 50, then he's got to be 50 here. So right now I have a total of 100. So X, well, let's think. 180 minus 100 is Good, 80, so x has to be 80 degrees. All right, let's do the second one. Again, I see this side is congruent to this side, so it means that this angle and this angle must be equal. I see I already have 100 degrees, so 180 minus 100 is 80, so I have 80 degrees to work with between two equal angles. So I'm going to divide him in half, so y is equal to 40 degrees. Next one. Well, there's a couple different ways to start on this guy. Trying to figure out where I want to go. So I see I have an equilateral triangle. This guy is equal to this guy. Then I have my base. But I also noticed that I have my angle split and a line in the middle. So let's go back to one of my corollaries for a moment, wherever my mouse is at. I'm sorry, theorems. The bisector of a vertex angle is the perpendicular bisector. So because my angle's cut in half, oops, one too many, sorry. Because this angle here is cut in half, I can see that by the congruency marks. This purple line creates a perpendicular bisector. So that means that I can draw in a 90-degree symbol here. Which means I have a new triangle I can use to discuss to determine the value for x. So I have 52 and 90, which gives me 142. So 180 minus 142 is 38. So x is 38 degrees. Now I'm going to undo some of that blue here. My right angle still stays though. Because he's a perpendicular bisector, I dealt with the perpendicular with the 90. The bisector means that it's equal and cuts it in half. So y has to be 4. Okay. This guy, I see I have a straight line. And the straight line's like a triangle, adds to 180 degrees. So this angle is 110. So 110 plus some random amount more gets me back to the whole 180. So 180 minus 110 would have to be 70. So this is 70 degrees. But then this side is congruent to this side, which means this angle must be congruent to this angle, so y has to be 70 degrees as well. And then the whole thing has to add to 180. So 70 and 70 gives me 140. 180 minus 140 gives me 40 more. So x has to be 40 degrees. I'm going to move that next time. Sorry, I'm making a mental note to myself. All right, next we're going to finish this guy up. We got 8, 9, and 10. I don't know why that just jumped on me. That was odd. Use figure to the right to determine the value. So again, I'm going to do some writing and then some erasing. I'm wondering if I can blow this guy up any bigger. Let me make my picture a little bit bigger so I can manipulate. Yours is pretty large already on your piece of paper, but my fat fingers on my computer screen is kind of hard to deal with, so I need to make them bigger if possible. I can write perfectly small with my pen, but with my finger, it's rough. Okay, angle L is 58 degrees. Find LKJ. Where's LKJ? So we're finding this guy here. Well, if you notice, I have a triangle. Triangles add to 180. I already have 90 of it, which means I only have 90 left. So 90 minus 58 would be 232. Oh, hey, I didn't read this correctly. My last letter is a J, not an M. So the question mark is 32. That's correct. However, I actually want not this triangle, and I'm going to do that again. I want the whole big angle. So if half of it is 32, the whole thing, you double it, is 64. Sorry, I read that last letter wrong. I thought I said M, not J. Whoopsies. All right, next one. If JL, that's the whole bottom, is equal to 5, then ML is equal to what? Well, I see that my big angle is cut in half, and I see a right angle, so that's my perpendicular bisector. So if the whole thing's 5, that means it gets cut in half. So 5 divided by 2 is 2.5. Next one, if JKM is 48 degrees, then what's the measure of angle J? So it's this guy down here. Well, if the right side of M is a 90 degree, the left side of M also has to be a 90 degree. So that means that I have 90 left to work with after I've counted off that right angle, minus 48. Oh, what? That gives me 42. And then my last one, if angle J is 55 degrees, then J to K to M is what? Well, again, I took off the 90, so 90 minus 55 is what, 35? Good luck on your homework. I'll see you for the review.